what's up, interweb? I'm going to try a couple of new things here. Welcome back, everybody. Hope everybody's doing well and haven't got the coronaviruses. Y'all don't worry about me, I'm here all by myself. Probably all eat up with the diabetes and the mad cow. Okay, if we're going to add and subtract radical expressions. Now what's a radical expression? If we have the square root of 5 plus the square root of 5. What do we have in front here? What is the coefficient? It's actually a 1, we just don't write it. So if we have the same number under the radical, these are like terms, so we can add them. So the square root of 5 plus the square root of 5 is 2 square roots of 5. Okay? Pretty simple, huh? Now let's take it one step further. If we have 3 times the square root of 7 plus 4 times the square root of 7, are these like terms? Yes. We have the square root of 7 and the square root of 7. Now, everything here has to be the same. If it's not, then they're not like terms. Okay, so we have 3 square roots of 7 and 4 square roots of 7. That is 7 square roots of 7. Isn't that clever? Okay? Okay. Now, what if we have this? If we have negative square root of 6 plus the square, 8 square roots of 6, are these like terms? Now again, in order for them to be like terms, they have to have the same radicand. Remember, the radicand is the number underneath the radical. And the same index. Now the index is, if we have the square root of 4, there's actually a 2 there, we don't write because we don't have to. And the cube root, those are the indexes. Now would these be like terms? No, because the radicands are the same, but the indexes are not. So those are not like terms. Well, I just looked at myself on here. Good Lord, I'm ugly. Oof. And stupid. Okay, so are these like terms? Yes. Same index. They have a 2 in here. We just don't write it. And we have the same radicand. Those are the same. Can you be more stupid? This is supposed to be a 2 here. I'm sorry. Golly. Well, I take a few days off and I can't remember anything. Okay, so we have negative 2 square roots of 6 plus 8 square roots of 6. All we do is we just add the coefficients, the numbers in front. Excuse me. So that would equal 6 times the square root of 6. Anything else we can do there? No. Everybody okay with this? Okay. It's real simple, just a little different. Okay. Now, what if we have this? What if we have 5 times the square root of 24? Can we factor the square root of 24 where one of those numbers is a perfect square? Now the perfect squares, I think I gave you a sheet on this. 1 times 1 is 1. Can y'all see that? 2 times 2 is 4. 3 times 3 is 9. Okay? This is 1 squared, 2 squared, 3 squared, and blah, 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 blah. Right? So what we want is, these are the perfect squares. 1, 4, 9, 16, 25, 36, and so forth. Right? 1 times 1, 2 times 2, 3 3 times 3, 4 times 4, 5 times 5, 6 times 6. Right? Right. So can we factor the 24 into something where one of those numbers is a perfect square? Yes. Will 1 go into 24? Yeah, but that doesn't help us. Will 4 go into 24? Yes. So that equals 5 times the square root of 4 times 6. 4 times 6 is 24, so we're correct. Now, can we take the square root of 4? Yes. It's 2. So this equals 5 times 2. Okay, the square root of 4 is 2 times the square root of 6. Can we do anything to the square root of 6? No. So what does this equal? Now remember, everything in here is multiplication, so it's 5 times 2, which is 10 square roots of 6. Right? Right. This is really pretty simple. It's just a different way of looking at these things. So what if we have this? Get this if you're so smart. What if we have x times the square root of 75? Now, 75 is not a perfect square, but can we factor it into something that is? Yes. This is going to equal x times the square root of, will 2 go into 75? No. Will 4 go into 75? No. Will 9 go into 75? No. 16? No. 25? Yes. 75. So it's 3 times 25. 3 times 25 is 75. Now, so what does this equal? Square root of 3, nothing we can do about that. But the square root of 25 is what? 5. Oh yeah, I knew that. Yeah, 5. So 5, actually plus or minus 5. But 5 times x times the square root of 3. Okay, the 5 comes out, because the square root of 25 is 5. 5x times the square root of 3. Right? What could be more fun than this? Well, this online stuff's a real pain in the neck, you know. I bet you I spent 10 times as much time on this as the other regular classes. Okay, what if we have this? Get this if you're so smart. Okay, if we have 3 times the square root of 24 plus the square root of 54. Well, what's that? Can we factor the square root of 24, where one of them is a perfect square? Yes. So it's 3 times the square root of 4 times 6. Right? 4 times 6 is 24. 4 is a perfect square. Plus, now is there something we can factor 54 into where one of them is a perfect square? Yes. 9 times 6 is 24, right? Right. So this equals, now the square root of 4 is 2, and 2 times 3 is 6, because it comes out of the radical. So 6 times the square root of 6, plus the square root of 9 is 3, times the square root of 6. Right? Right. Now, can we combine these two terms? Yes. The number under the radical are the same. They're both 6. And the index is the same. They're both 2's. So can we combine these two things? You betcha. So 6 and 3 is, let's see, 6 and 3. 30 days of September. 6 plus 3, carry the 7. Was that 9? I knew that. 9 times the square root of 6. And there's our answer. Now again, what we want to do here is the number under the radical is called the radicand. The radicand we want to factor into two numbers where one of them is a perfect square. Okay, 1 of course will go in, but that didn't help us any. 4 will go in there, that's right. 9 won't, 16 won't, 25 won't of course. Now 54, will 4 go into there? Not evenly. 9, yes, 9 times 6 is 54. Okay, and then it's just a matter of of taking the square root of 4. And when you take it out, remember all this is multiplication in here. So it's 2 times 6, 2 times 3 is 6. And this one, same thing. What's the square root of 9? 3. And the 3 comes out of the radical. So 3 times the square root of 6. Now these two are like terms because they have the same radicand and the same index. So we can combine that. 6 and 3 is 9 times the square root of 6. This is good stuff, huh? Almost makes you want to wish you had the coronavirus. Okay. Okay, what about this? Two times the square root of 20x minus 45, square root of 45x. Now let's factor the 20x into a number where 1 is a perfect square. Well, 1 going to 20, let's not even consider 1 because it doesn't really help us any. Well, 4 going to 20, oh yeah. So we have 2 times the square root of 4 times 5, don't forget the x, minus the square root of, okay, what'll go into 45 evenly? Well, 4, no. Well, 9, oh yeah. 9 times 5, and again, don't forget the x. Now, we can take the square root of 4 and we can take the square root of 9. Square root of 4 is 2, and 2 times 2 is equals 4, okay? Square root of 4 is 2. 2 times 2 is 4. 5x minus, the square root of 9 is 3, so it comes out of the radical. 3 times the square root of 5, and again, don't forget the x. Now, are these like terms? Yes, because the radicands are the same and the indexes are the same. So this is going to equal, let's see, 4 minus 3, 4 birds on a wire, 3 of them fly away. Oh yeah, 1. So it's the square root of 5x. Now we also have to say something here, that x has to be greater than, I guess it could be greater than or equal to, yeah, it could be equal to, greater than or equal to 0. Why? Because again, if x was a negative number, then we'd have a negative number for the radicand, and without using imaginary numbers, that would be no good. Okay? Okay, I guess about the only good thing about this online misery is you can stop and rewind if something doesn't make any sense. Okay? Okay. Okay, what about this? If we have 5 times the square root of 3 minus 4 times the square root of 7. Now both 3 and 7 are both prime numbers. They cannot be factored, right? Right. So can we combine these two things? No. The radicands are different, and the indexes are the same, but the radicands are different. So this would be, I guess you could say, prime. It's not factorable, and it's not combinable. Can't combine them. So the answer would be this. Okay. Okay. I'm going to take a break. My back's killing me.